Here we are at lesson 1.2, modeling with graphs. When we model in algebra, we're using an equation, a graph, a table, one or two of or all three of those things to represent something that's happening in a real world. In our last lesson, we tried to anticipate what a graph would look like of Professor Splash's fall on his 36-foot belly flop into a 1-foot pool of water. In this lesson, we have the graph. We also have an equation that represents that, and we have a table. These are all connected. If I type this equation into a graphing calculator, then it will give me the graph. And it could also give me the table, or I can compute those by hand. So to fill out the table, the time is x and the height is the y value. I can substitute 0 for the time in the equation. So the height is equal to negative 16 times 0 squared plus 36. And I can do that arithmetic by hand, or I can put it in my calculator. Remember, exponents are first, so 0 squared is 0. Then that gets multiplied by negative 16, which is still 0. And when we add 0 plus 36, we get 36. Of course, we knew that because it was a 36-foot belly flop. But that just lets us know our equation is working. Now, if we have many values that we need to find, then we can let the calculator do all that arithmetic for us and save us some errors on it. So let's go to the calculator, and let me show you how to put that in your calculator and find those values. As long as you have an equation that's solved for one variable, like this one is solved for h, you can put it in your calculator in terms of x and y. So h is the y1 right there, and then we're going to type negative 16 and then use the x that's next to the alpha button, and here's a square shortcut right here, and then plus 36. That's my equation. I want to set a window for my graph that matches what's on my paper. So my x-min should be 0, my x-max should be 3, and I can navigate by using the arrow keys or just pressing enter. My y-min needs to be 0, and my y-max needs to be 40. That just gives me a picture like what's on my paper. Now if I trace by pressing the trace button, you notice along the bottom it gives me an x and a y. That's an ordered pair. You can also see, I can use the arrow keys to move the cursor on the graph. I have to be in that trace menu in order to do that. And so it gives me an x, which is time, and a y value, which is height, that correspond with each other. I want a very specific time and height to fill out my table. So I can try to trace to that, or I can just type in the x value that I'm looking for. And remember, x is time in this problem, and press enter, and it will jump directly there. You see the cursor on the graph, and we see the ordered pair at the bottom. So we can use that information to fill in our table. Now I also want to know what is the height when the x value is 1. I'm still in that trace menu, so if I just type 1 equals, then I see my cursor move to that point on the graph, and I see the ordered pair 120 that I can add to my table. So let's talk about the meaning of some characteristics of the graph. The y-intercept is where your x value is 0. So x is equal to 0, and then the y value that goes with it. That is where the graph touches or crosses the vertical axis. So we could write that as an ordered pair, 0, 36, in our problem, and what that represents is the starting point. And we know that he started from a platform that was 36 feet above the ground. Now the x-intercept is where the graph touches or crosses the horizontal axis. In this case, that looks to be about 1.5. And the y value is equal to 0 there. So x is 1.5 and y is 0. In this problem, that represents ground level because the height is 0 there. Height is the y value. The point of intersection is where two or more graphs cross. So if we were to illustrate our 1-foot pool of water, 0 is ground level, so at about 1 foot that could represent the water level. So he hits the water and then almost immediately hits the ground as well. So where those two graphs intersect is the point of intersection. So it's roughly at 1.4 for the x value, and then we know that that y value is 1 foot. Let's go to the next story. We have two submarines. Submarine A is 900 feet deep and rises at 50 feet per minute. So 900 feet deep is the starting point. That would be below ground level, so that's why our y-intercept is at negative 900. And rises at 50 feet per minute. That means that after 1 minute, our time is in minutes, so after 1 minute, the submarine is at a depth of negative 850. And every time you go over to the right, one grid mark, that's another minute, then your height is going up by 50. So we get this series of points that lie on a line, and we can actually connect those with a line. We can write an equation to represent the depth of submarine A by letting the time be x and the depth be y, and you can use other letters for that. You could use t for time, and you could use d for the depth. But if we look at our template for the equation of a line, y equals mx plus b, b is the y-intercept, or the starting point. And you can see that our starting point is at negative 900, so we can make that substitution. The x stays in the equation, and so does the y. The m is our slope, and that is the rate that it's changing. And they tell us that it's rising at 50 feet per minute, so that's our slope, 50. This equation can help us fill in the table, or we can fill in the table by looking at the graph. So at 0, we're at the y-intercept, negative 900. At t equals 2, we're at negative 800. And at t equals 4, we're at negative 700. Now submarine B is on the surface at the beginning, and so that would be at 0, which is on the x-axis. And it submerges, which means it's going down, at 100 feet per minute. This is the rate. So if we use that template again, y equals mx plus b, we know that our starting value is 0, so we have plus 0. The x stays in the equation, the y stays in the equation, and we want to substitute for the slope, which is 100 feet per minute, but since it's diving and getting smaller, we have a downhill line, we're going to have a negative on that slope. Now usually we don't write a plus 0, we're going to clean up this equation and call it y equals negative 100x. Use that equation and plot the points on the graph and fill in your table. The point of intersection is the point that the two lines share. It's where they cross. And you can see those cross on the grid, so we could write that ordered pair, which happens when time is 6 minutes and the depth is at negative 600. Now what that means in the context of this problem is that at 6 minutes, both subs are 600 feet below the surface. Using an equation and a table, we can graph anything, and we don't have to have a scenario attached to it. Now, anytime we're substituting into the equation with repeated arithmetic, there's a likelihood that we're going to make an arithmetic mistake. So I'm going to show you again how to put this in your calculator and to fill in the table and to sketch your graph. So this is where we left our calculator, and we need to go back to y equals to put in our new equation. We need to get rid of what's there, so we're going to press the clear button. And then we're going to type the square root, which is the second x squared button. You can see the blue up above the key, which tells you that that's what you want to type in. And then we type in our equation using this x plus 5, get out from under the square root, plus 1. Now I just want a window that goes from negative 10 to 10. like I have on my paper. And so this is what I get back. Now you don't want to just slap that on your paper. You want to be very precise. We want to fill out our table. So let's press the trace button, and then let's enter our first value for x, which is -5. After we press trace and enter -5, then we get the y value that goes with that, and we can plug that into our table. The next value that we want is -4, so we type that in, press enter, and we see when x is -4, the y value is 2. If we substitute -1, then we get a y value of 3. If we substitute 0, then we're going to get this decimal right here. If we substitute 4, then we get 4 back. And then let's substitute our last value of -9. And you see when I substitute -9, there's no y value that goes with that. And that's because if I substitute -9 by hand, I'm going to have -9 plus 5 under the square root and then add 1. When I simplify under the square root, I get the square root of -4. And square roots undo squaring a number. You can't have a negative number underneath your square root and get a real number back. So this is not a real number, and that's why there's no graph there. So we can just put error on our table and fill in those other values that we found. So then plotting those points, remember to count from your origin. Your x value is horizontal, so -5. Your y value is vertical up to 1. There's our first point. -4, 2, -1, 3, and then 0 is a little bit bigger than 3, and then 4, 4, and then based on the graph we had in our calculator, we know it's going to go that way. There is no graph for values smaller than -5 because they do the same thing that -9 did and cause a result that's not real. They cause a negative underneath the square root. Let's look at the last story problem. Timmy and Kate are at the arcade, and the graph shows each person's quarters over time. So they start with a certain number of quarters. They're spinning them in the games at the arcade, and so they have fewer and fewer quarters over time. Maybe we can fill in our table from the graph. We'll try that, but we also want to write the equation for this. Let's look at Timmy's graph, which is in red. The time is the x value, and the number of quarters is the y value. So when the time is 0, you can see the y-intercept is at 40, which means he has 40 quarters. At time 0, that's what he starts with. When time is 4 minutes, then the graph is at, the y value is at 30, and then at 14 on the red graph, the y value is at 5, which means after 14 minutes he has 5 quarters left. Let's write an equation for that line. He started with 40 quarters, that's our y-intercept, which is our b in our template for a line. So we're going to put plus 40. The x stays in our equation, and we need to substitute for the slope. The y is going to stay in our equation as well, so we just need to substitute for that slope. If we go to our graph, we see that if we go down 1 grid mark, that's actually going down 5, so -5 since it's down, and then we go our run, which is over to the next place where it crosses the grid, and that's actually over 2. So this is a downhill line, and we have a negative slope, -5 over 2. Now you can see that in your table as well. If you did the rise, 40 minus 30 would be 10, and then the run, 0 minus 4 would be -4, and then that would simplify to -5/2 as well. Pause the video and try that same thing to fill out Kate's table and to write an equation for her experience. I hope you pause the video and check your equation, and then also check the meaning of the y-intercept, the x-intercept for Timmy, and also the point of intersection. And then do your practice.